in the Nokia use case, lots of things are all part of one big Kubernetes cluster. And these things are not in the same building. There's cell sites and little buildings at the base of cell sites. And there's intermediate places and there's central offices. And all those links have to be encrypted. All the keys have to be rotated regularly. There's a whole bunch of security things you have to have around it. And whenever software gets updated, it has to be updated in a disciplined way where all that stuff where all those connections and links are maintained across software updates. Service Mesh is an excellent tool for that. It's a really good tool for it. And you add to that, it needs to work in a multi-vendor environment. Then it becomes a big mess. And it's not an unsolvable mess. It's just a lot more complicated than the original Kubernetes sort of clean vision. Mm-hmm. And so it's all okay. It's just it's interesting when I apply these things to my work situation. So one of the things we had one of our customers says, okay, that's your floor space. Do it all in Kubernetes, but that's your floor space. Whatever you want to do, bring your servers, run it on AWS, bring it on Google. That's your floor space. Do whatever you want to do. And vendor number 2, get your own cluster, do your own thing, and interface between each other using industry standard interfaces. And so you're just separating clusters as a vendor management tool. Now, that's not the only way to do it, but that was an example case of one customer getting frustrated by how much detail they had to be involved with for 2 vendors to work in their solution.
So you use Calico for that, right? As I understand.
No. Calico, my home network. Calico.
Okay.
No, I got a home network now, right? So I got a home network. I got 3 Dell servers in the basement. They're running Kubernetes version 1.129. I do lots of applications, and my newest one is Contour Ingress Controller.
So Jack, have you played? Since you have servers, right, and you have one cluster, have you looked into vCluster?
Yes. And I'm more inclined to do Kind.
No. The vCluster. Oh, running Kind on that Kubernetes cluster.
Running Kind. No, I got 3 nodes, and the 3 nodes are running. And I can
kubeadm. I think you told me you were deploying with kubeadm, right? You set up kubeadm and deploy
on three clusters, and I just have another server or just run Docker containers. And
so I was trying to say
I'll run it on my server that just runs Docker containers.
No. So what I was trying to tell you was like vCluster is a cool technology that you can launch on top of that physical cluster.
Oh yes. I'm familiar.
And then you can create like a 125 and 126 and 131. You can have different versions of Kubernetes running on top of that Kubernetes cluster, so you can do like testing or evaluation or delete something and try something and play with something and then delete it, that you don't have to touch ever your the first physical
I'll give it a try
at all.
Just like I gave Contour a try, I'll give it a try. I just have been using Kind for those kind of exercises. I was at a conference a couple weeks ago where people were talking about using Kubernetes as a way of saving money, and they needed to offer.
Wait a minute, to save money. I should cut this part. I'll cut this part. Go ahead. I want to hear how people save money using Kubernetes.
Oh gosh. So they're running a multi-tenant system. Okay. Present mode of operation or old mode of operation is each customer gets their own virtual machine. Each virtual machine has a monthly cost from AWS.
Ouch. Or any cloud provider, right?
Or any cloud provider. This particular person who could have been using DigitalOcean, I have no idea what they were using. And then they discovered that if they got a 3-node Kubernetes cluster, they could put all their customers with headroom for more customers, all on 3-node cluster. And instead of having a virtual machine per customer line item bill at the end of the month, they had one Kubernetes cluster. And it actually saved them money because they were able to aggregate onto a smaller number of virtual machine equivalents. and they were like, you guys have to use Kubernetes for this. If you just keep doing virtual machines and Docker, you're not going to be able to get this kind of savings because. So then they described one of their set of customers was the utility customers. So every time there's a power outage, everyone messages and calls the utility company all at once. Huge spikes. And those huge spikes, their Kubernetes provider just spins up more, just the basic replica sets, just spins up more capacity, and they can handle the capacity just fine. And then it all disappears when the power outage goes away. And they were showing the graphs and stuff. And of course, they spent more money at the end of the month when there was a power outage for one of their customers because it was a huge traffic spike. But that's how they saved money with Kubernetes. So this is the conference where they were presenting Kubernetes as a cost savings. And I thought when they presented that, they said, "Yep, this is just what Nokia would say. This is spot on for value proposition. If you split things up. Now, if you're AWS and you're trying to maximize the number of billable items, Kubernetes actually lets you consolidate things. And so I suppose you could argue that you could make it up by adding load balancer instances or adding or other kind of ingress interfaces that you have that are billable. And stuff. But anyway, that was an example. That was an example that were at the conference I was at. And so you should go. You should go next time.
That's exactly word by word the Kubernetes story, right? That we everyone that is using Kubernetes and is using it for exactly that, to bin pack, right? To bin pack, to have containers,
bin pack, yes,
to have isolation, right? You're bin packing and maximizing the utilization of that server that you're paying for the hour that is not shutting down, right? Maximizing the usage and not having utilization down, like you said, like they were given a server and then the CPU was like 2% used, right? And the other one is just cost. So that's exactly the message that the Kubernetes community is trying to give. And then the flip side, sometimes it gets convoluted with, it's not worth it because it's so complex to operate or install or upgrade or like secure or like share. But I think I'm the opposite, right? It's worth those complexity because I did operations before Kubernetes and container existed. This is how old I am, right? And then came containers, and then came Kubernetes. Life is much better and costs less than before, right? That you were saying, giving every customer an instance or a VPS for that matter.
Right. So that's an example. That's an example. And then I would say the recurring theme is everyone at this conference has a monthly Google, Amazon, or Azure bill that they're trying to manage. And they're very sensitive to, wait a minute, if I use that can become another billable item. It becomes part of the engineering exercise of how to efficiently build something.
In our company, we have a cost optimization. We have a cohort. We have strategy, and a lot of people working on like how to do cost optimizing. And one of the tools is that was created recently, and it works in both in AWS and Azure. Is Carpenter, which is to maximize the selection of those machines. So that's the next level. Like you were saying the story about like, they created 3 nodes or 4 nodes. The Carpenter project is around selecting what type of node is the most efficient one, right? Is it the one with 4 CPUs and 8 gig of memory, or is the one to 2 CPUs or 16 CPUs? Is it the ARM one? Is the x86 one? And they go, and then the next thing that it does is like, hey, wait a minute, this machine has 2 pods, this other machine has 2 pods. We should consolidate. We should have like one machine that has the 4 pods, and even like lower the size of this machine and then get a cost savings of 80%, for example, or 60%. That controller would do that. It's called Carpenter.
I've heard of it on the podcast. I haven't ever. It hasn't registered with me. Is it something that's AWS only, or can I use that?
Azure. Yeah. Okay. It was Azure. It was invented by AWS because of this thing that I was mentioning. Like we are optimizing. But yeah, it's a Carpenter. I went v1.0 the other day. The API is now stable, so that's something that like cost optimization is coming up, and Azure was Azure and AWS now they're working together, and they have implementations for that. And it's a small, it's not the whole thing, but it's a controller, right, that helps you select that you mentioned, like the like before this you will needed to decide, like, am I going to, like, your Dell machines, you cannot do your Dell machines. You cannot swap them, right? There you decided that the size of how many gigs and CPUs fit in that machine. But in the virtual world, right, where we have VMs in the cloud providers, then you can swap one for another, and then it's just the size that they have.
Yeah, very good. Very good.
Actually, I was not presenting the website. I just showing the website. I was presenting the book. I had a question for Sergio on the designing. So this is Carpenter. I think .sh for some reason. And it went 1.0. I think it was a week ago, right, Satish? I think a week ago when 1.0. I'll be giving some talks in KubeCon on it, and we have a booth on that.
You did something live, right? A few weeks back.
Yeah, I did a best practices Carpenter live stream. Yeah. I was promoted in LinkedIn and I think Twitter also, with a solutions architect from Europe. So I was going to ask, I was mentioning this because Jack was mentioning, like, when you're designing a system, you have to, what are the challenges? And I think I remember reading this chapter 15 that Sergio wrote, when you design your system, right? It's here, like cost and security and automation, right, Sergio?
Yeah, it's something like this link canvas. Do you remember when we are studying like startups and entrepreneur stuff and that kind of things? This is a kind of link canvas, but applied to edge computing more or less. That's the idea behind this chapter, to create
like this
like a
design
kind
here,
of,
right?
Yeah, that canvas.
The edge computing design system design canvas, and you have metrics here. We discussed metrics last week. We showed Prometheus and Grafana. We went through that chapter, and I got Prometheus and Grafana working in my Jetson. And Satish here also is also an expert in Prometheus and Grafana, what I heard about working on EKS and all those Kubernetes in the cloud thing.
Yes.
But yeah, this one, I think is this the last chapter or one of the last chapter? Oh, here it is.
Yeah, it's the last chapter.
Using managed service provider, right? The topic that we're talking about.
Yeah.
So what did you include it here?
AWS. The major providers: AWS, Google Cloud, Azure. I don't know if Sivo is mentioned there.
Okay. Yeah, and you mentioned the K3s, and then I think the hardware projects that you mentioned through the book, right?
Yeah.
What is RockPI?
RockPI is like, well, it's hardware manufacturer or something like that. Like they create a kind of powerful kind of Raspberry Pis and different devices for edge, but not just edge. Include edge devices, tablets, laptops, and that kind of stuff. So they're pretty interesting.
Interesting. I never heard about it. And Pine64?
Yeah, Pine64. Sorry, that's Pine64. RockPI is a manufacturer from China, I think. That are pretty interesting too. Yeah.
That manufacture Raspberry Pis or boards are based on Raspberry
boards,
Pi?
Yeah.
Interesting. And then Pine64 was what, the one that you mentioned?
Yeah. I think that both. RockPI looks like more for machine learning stuff. Pine64 like more in general kind of hardware devices. Yeah. So are pretty interesting projects.
And ESP32, is that
A
Only
microcontroller.
Arduino. They only support Arduino. It's an Arduino base.
No. ESP32 is like a different microcontroller. I think that this
Ah,
becoming like a kind of the new standard for microcontrollers for IoT.
I've seen it in many places, like ESP. But the links, the reason I said Arduino is the link says healthtech.org/ESP-Arduino. That's what I
Let
was
me see.
asking because I'm
Can
familiar.
use.
I did some. I have. Yes, I have every hardware device that came out. I have an Arduino, probably two, in this office. And I have all the cables and goes. But
Mhm.
I didn't do much because the programming language. I think it was C, and it was very
Yeah, for
hard.
ESP30,
And then
yes.
I think it was like maybe 10 years ago. Card. I don't know when
Mhm.
Arduino came out, but I think I got it 10 years ago. But then I bought something that came out called Espruino, and
Um,
it was a little chip. I was in a what you call it when you give money to fund an experiment from someone. What's that webpage?
Kickstarter or something like
Kickstarter.
that.
Yeah,
Ah,
Kickstarter. So I gave money. I think it was
ah,
$20 or $10
mhm.
for a chip that was an ESP microcontroller, but the
Ah,
operating system was programmed with Node.js, so it was
ah,
JavaScript.
ah,
And at that
interesting.
time, I was a web developer,
Mhm.
and like I'm not dealing with C. Like C is so difficult. I would just want to like turn on a light. So I think I bought that one, and it was amazing. Like it was JavaScript. You write the JavaScript for the lights, for the sensors, for everything, and then you push it to the device, and it's a little device. And at that time, like nothing can run no like JavaScript, right? A JavaScript runtime doesn't have to be Node.js. JavaScript is something that's different runtimes. That are
Mhm.
very very small that can run on hardware, and that was one of the first ones that came out that runs
Mhm.
in like for low footprint hardware, and then other runtimes that were very typical in Java. So I used to do a
Mhm.
lot of like JavaScript runtimes in backend servers back in the days when like
Mm.
a lot of people used to have like Westphere and Tomcats and those type of things to write
That's your,
JavaScript
yeah.
functions, backends to make it simple instead of writing a servlet. Right, people would just
Mhm.
wrote little JavaScript function that ran in the backend that was run in a Java runtime. Java was running the Node.js runtime.
Mhm.
Hey Carlos,
So I,
these this Raspberry Pi, right? These just for hobby or they have them real commercial?
No, you
Use?
can use the Raspberry Pis for production.
Oh,
yeah,
Yes.
they do. Okay.
Yeah. But let's say, for example, they are like in some places they sell you like the Raspberry Pi, but with a different case that support weather, like heat, cold, and that kind of stuff. So more for
Oh,
open environments, indoors, outdoors, and that kind of stuff. Like it depends on the kind of industry that you are using this kind of device. Is the thing that has to support like.
yeah.
okay.
I have a friend, one of someone actually works in AWS. He lives here near Cary, and he has a piece of land, like an hour, 2 hours from here, and he has
Mhm.
chickens, and he has like chickens and things like that, and he's using a Raspberry Pi right out
Mhm.
there, and he can it's connected to the internet through cell. I think it was 3G or 4G, and he can open the gate for the chickens, and he has a
Yeah.
camera there. And I told him that I need to go and see that because my wife is loves uh, chicken and taking care of chickens and hens. But yeah, he told me that, and I asked him like, what do you use? And I use a Raspberry Pi. And like, really, you use a Raspberry Pi? Yeah, a Raspberry Pi with a case, like Sergio was saying, it has it in a little box, and
Mhm.
it's connected to the internet. And from home, he's taking care of the of the chickens. And then says like every Saturday he goes and picks eggs. Rides there and gets eggs.
Okay,
So yeah,
so Sergio, for
Yes.
your edge computing, could you talk anything about the edge computing as defined in the 5G standards?
No, no, it's not included.
Okay. So for example, Verizon offers a 5G edge computing solution
Mhm.
for enterprise customers. And the reason why you have to do edge computing with 5G is 5G offers very, very low latency configurations. So for an enterprise who has a special need for low latency,
Low latency.
you don't want things to go all the way back to some data center in New Jersey and then all the way back to your factory in California for a low latency service. So what you do is you set up an edge computing endpoint, part of your cluster, but an edge computing endpoint on the enterprise's cell site, campus, and so the 5G's traffic stays local for the low latency implementations. To do that, Verizon, of course, Nokia wanted that business. Verizon awarded that business to AWS. Now, are you familiar, Carlos, with the Outpost solution from AWS?
Yeah.
Okay, so that's an example. Maybe it's a different. Maybe this is edge computing and then edge computing prime. But this is an example of how the 5G industry uses edge computing. Edge computing is an orderable item, an enhanced feature on top of 5G for enterprises. And AWS is the platform that Verizon chose to deploy that because they needed to have Verizon told us they need to have a development platform that the enterprise customers were familiar with because they're the ones who are going to have to make the low latency service work for them. Verizon doesn't know their business as well as they do. So that's an edge computing hand wave. And it's another example of edge computing. So when I saw your title, Edge Computing and Kubernetes, I was wondering if this was in scope for you because it's in the marketplace, a revenue generating feature service.
Interesting.
Yeah.
The only thing that
we have-
I included was like for more production kind of stuff was like this LoRa protocol in way to communicate to long distances without using the 5G, right?
Oh, LoRa's really cool. LoRa's really cool. But the problem they're trying to solve with LoRa is they want to have a device they can stick in the ground and not have to change the battery for 10 years.
Yes.
And so you tell the device, we're only going to talk to you once a day. So all you have to do is turn on your receiver once a day. And if you hear anything, then turn on your transmitter and respond. Otherwise, you're just off. And so it's very, very low power. And so
yes.
your mobile phones are always on and always sucking battery. These IoT devices just can't work that way. You can't afford to change the batteries every year.
Carlos, and that's the reason that the ESP32 comes to this game because of LoRa.
LoRa. Oh, okay.
They have like good support for LoRa.
Yeah,
I see.
It's very low power, and the radios and smartphones are like always on and always burning, and so they have very careful optimizations in the smartphones so that your batteries last a day. And anyway, it's just interesting. It's just interesting. I'm glad to see you had an edge computing book on the subject.
Yeah.
So is that a hardware? You said Lord or something. Is that a hardware?
Yes.
Jack? Okay.
I think that I have an example. I'm going to pick my LoRa. Give me a second.
Okay.
Go ahead. Yeah, he has a device, LoRa device for that.
Okay.
About the running Kubernetes on the edge, low latency. Not that it's the only one, but the one that maybe Jack was showing was AWS has this thing called AWS Local Zone for low latency, and you can deploy EKS, right? The managed Kubernetes into that lower latency environment, and AWS supports that scenario if you need like telco companies are the ones using that.
Yeah,
also Netflix also.
LoRa. Okay.
LoRa. It's long range radio.
Okay.
Long range radio. It's a special kind of just like there's LTE and there's 5G. Well, there's LoRa. It's a different radio technology, and it's got very low capacity. So how our phones have enough spectrum and power to watch Netflix. Some of those devices don't have enough power to run a TCP/IP stack. They're the
Oh wow,
the
that low.
they don't TCP/IP. That's too much power. That's too much over the air wasted paths. They just don't have. They're just really skinny, and because 10-year battery life, 10-year battery life.
Wow.
Yeah, that was the reason to include LoRa because, like, well, let's say that the book maybe is more focused on manufacturing kind of edge computing solution, not as 5G, something more like a big scale. I think that telco things are more like a kind of a special use case or an specific use case. But yes, I think that I was reading that LoRa, or I don't know if telco compete or are or LoRa is a contender for 5G or something like that. But
No, not
I
really.
was reading
5G.
something about it.
5G, there's something called 5G Red. Red stands for reduced, 5G reduced, where there's a version of 5G where, you know how 5G has a maximum of like a gigabit per second download? I think
Yep.
5G Red has a maximum of like 128K download. It's very skinny 5G. And there, it probably doesn't directly compete with LoRa, but it's a very low power 5G.
Yes.
Lower
5G
power
Red,
4G.
red,
Interesting.
whatever red stands for, reduced
Yeah, these are some of
functionality.
the use cases. This one, smart mirroring, like taking your electricity usage, right? Bill, like when I was a kid, I remember seeing people going to my house and read the numbers, right? Very expensive task, imagine, right? And then years come by and all this information just flies back to the mothership,
Yeah.
right? All these electric from your house meters. And then for a while, when I was living in Puerto Rico, we didn't have it, and then back now the homes have these ones installed. But yeah, I remember when the person came by to read the meter back in the days, and now everything's connected. But yeah, it needs to last a long time, and places where there's not that much power or things need to run with battery for a long time, right? Um, just in case of emergency, when you lose power, you need to run as much as possible, and
Right.
mostly communications.
There's Zigbee, there's Z-Wave, and there's a whole bunch of other combinations of those that municipal networks use for like water meters and things. Power
Yeah,
companies use. Yeah. I
yeah.
just put a pointer to 5G reduced capacity. It was a nice white paper from one of our customers, Telnor, that describes it. It borrows from the spirit of LoRa, but it isn't as slow and it isn't as cheap, or it isn't as low power.
Mhm.
Yeah.
Let's see this one. I think this one you share. Let me check. Yeah, I started in my house. I have like a bunch of sensors. Like most of my lights, I start changing them to be smart and controlled to a. I have the Philips. What I found was, at least for me, the best one that I found was the Philips Hub.
Oh yeah.
Zigbee, and it does Wave. What was the other one? Wave.
Z-Wave, Zigbee and Z-Wave.
All the latest devices I bought are Zigbee.
Mhm.
So I have it, and it's better. At least like when it connects for the first time, it was easier to configure a Zigbee than a Z-Wave. But I don't know if because it was had more range to it. But yeah, I mean Zigbee. If I buy something now, I'll buy Zigbee. So the 5G, it's called Red Cap or NR. What is NR stands for?
New radio.
Mm.
Oh, new radio.
Right.
Okay.
LTE is old radio. Remember 4G? LTE?
LTE.
LTE is old
LTE
radio.
is old radio.
Yes.
I
LTE
thought LTE
and
LTE was the
5G's.
fastest and the best thing ever.
Well, yes. 5G though is new radio, and the new radio NR is the official name for 5G new radios. So what kind of radios do you have in your mobile phone? Well, I have an LTE and an NR.
Interesting.
So that's just nomenclature. It's actually a little tongue in cheeky. Yeah, that's okay. That's okay. And so the LTE does everything that it does. You can watch Netflix,
Yep.
60 miles an hour, 4K video, but it runs on the spectrum below 3 gigahertz. 5G runs on the spectrum above 3 gigahertz, all the way up into the double-digit gigahertz. And so one location at a time gets upgraded to really high speeds. Basically as business justifies. And so LTE doesn't have the option to to use that higher spectrum.
I see. That's the difference. Very interesting.
Yeah.
Very interesting. And
I
then
think
that gets us to IoT.
Yeah, I think my Ring cameras use Z-Wave. What does Ring use? I think Ring use Z-Wave.
I don't know. I don't know. I just have them all connected to my Alexa. All my Alexas in my house. So yeah. But the one thing that I install that is not smart, which is I think it's the best hack in my house, is I install sensor lights in my garage, because my daughter kept leaving the lights on in the garage every time she went there. It's like I had it. So I install, like, when you walk by, I install the sensor lights, and I put a masking tape on the switch, and like, don't touch the lights. Like, just go in, it will turn on. Don't. And then during the night, my wife doesn't have to tell me, did you turn the light off in the garage? Like, I don't care. So that's the best, and that's not smart or anything. It's just like one of the physical moving sensors with the light, right? So sometimes the plain and simple, practical, non-technological solutions are the best ones. So at least for that use case, that's the best hack in my house. Like, it saves me so much headache and energy that I don't have to think about it again. So I think we discussed a few things today. Going to close it out. A few people joined later. I saw Vinod, Chandral, who else? Nikhil. Welcome. We are looking, Sergio. I think we're ending your book, but it was very interesting. A lot of chapters. Like, it was Jack. I don't know if you were in one of the sessions. Jack said, like, this is a full Kubernetes. Like, all the practices in Kubernetes are included. It just happens that you have, on top of that, you have like Edge, but it's almost, I said, like, it's almost like the production Kubernetes. All topics are there,
it's
and
like best
applicable to
practices,
Kubernetes. Yeah.
So
you can learn
Sergio,
Kubernetes with the book.
You can learn Kubernetes with it. Yeah.
So Sergio, I got the best introductory explanation of ingress controllers from your book than anywhere, and so I thank you. And it inspired me to go add an additional ingress controller to my cluster, a Contour one. So thank you.
Interesting.
Yeah, we were discussing that, of like, you can have different ones, and you put the class, and Jack was talking about that.
Yeah, I think that I was writing each chapter if someone doesn't know anything about the topic.
Kubernetes.
Yeah, that's
exactly. Yeah.
And I was focusing the book for people from IoT to learn Kubernetes, or a DevOps guy to learn IoT.
Yeah.
That's true. That's true.
Good.
That's true, because that was me. I was the DevOps guy learning IoT.
Nice. Thank you.